Okay, so welcome everyone to the third lecture of our lecture series, MATLAB based modeling of nonlinear stochastic parametric oscillator system. So today, we will learn. First, we will today the main topic that which we will cover. So is basically plotting, and in the end, I will introduce you to the concept of function. So how to define a local function and what is the use of it. So in plotting, mainly we will cover 2D plotting and 3D plotting. So we have different kinds of plots. So we will go through them and we will write some basic code in MATLAB also to get familiarized with this thing. So let me proceed with the simplest kind of plotting, which is 2D line plot. So before proceeding, let me tell you why plotting is important. So whenever you have some data, so suppose you are running some experiment and you are getting some data out of it. So for example, suppose you are measuring the position of the displacement of the oscillator as a function of time. So you have a time data. So maybe it will have some numbers in it. So suppose these are the seconds, you are measuring the time at 1 second interval, and for this time you have some displacement data. So this is your displacement. So maybe so these are x. Suppose these are numbers x0, x1, x2, and so on. So x10. So now suppose, so what you can do to look at the trend of the displacement. So how the displacement varies as a function of time. So, is it sinusoidal? Is it decaying? So, to know that, what you can do? So, you can do the basically, you can plot the data. So, you have the independent axis here. So, here t is your independent axis, and you have your dependent axis here, which is x. So, you are basically plotting the displacement as a function of time. So you will have, so for this time you will have corresponding x value, for another t you will have x value. So depending on your data, it can look sinusoidal, it can look oscillatory, or so on. So these are the data points for from your experimental data, and if you plot it, then you will see a trend that there is a kind of exponential decay trend. So without analyzing the data, just by visualizing them, how it varies, how the displacement varies as a function of time, you can qualitatively tell about your system. So you can tell that your system is damped, and so your system, so it is exponentially decaying. So some basic idea that you can get about a system, and based upon that, based upon the trend, you can consider your model. So visualizing data is the first step of analyzing. So if you can visualize it properly, so then you can proceed with proper mathematical techniques to tackle to your data. So it is always important to observe how the your data varies, how the data that you are taking is varies. Or also, so you can have some complex mathematical functions. So for example, you can have x cube. So for example, if you have, so suppose you are given two functions. So one is, suppose, maybe x square e to the power minus x. So if you look at it, so maybe at x equal to 0, it will be 0, and at x equal to 1, it will be something like e to the power minus 1. So 1 by e. So it will have something maybe like this. And suppose you have another curve. So for example, linear, just for example, just x. So x as a function, so this function, so it will varies like this. So if you plot both the data, then you can, so for example, you want to know, suppose you have two functions, so you want to know where they intersect. So one thing you can do, so you can look at the, so where they intersect, so their functional form should be equal. So if x is the intersection point, then you should have this condition satisfied, and also by looking at the data, so you can know where the point intersects. So visualizing data is always essential. So in any kind of so be it experimental or be it your analytical model, or you're considering any, you're doing any simulation. So always visualizing is the first step of analyzing. So let me show you how to visualize or how to plot in MATLAB. So the basic kind of thing is 2D plot. So 2D line plot. So what is this 2D plot? So in 2D plot you have one independent variable. So for example, x is your independent variable. So this is independent, and so you have independent variable. So this is dependent, and y, so which is a function of x. So so for example, you have y equal to sine x. So you know how this graph look like. So as a function of x, you in this axis you have y axis, and if you look at the sine curve, you will see it will have some oscillatory kind of behavior. And since it is so, something like that. So since it is proper sinusoidal, so it will not have any exponent, it will not have any decay or amplitude change. So it will be a perfect sinusoidal which will go on for infinity, y equal to infinity. So you will have this oscillatory motion. So you know that how this sine curve look like. But how are we getting it? So basically, when we are plotting it, so so in coding, so what you will do? So first you will give the x array. So you have, so here, in x-axis you will have some points. So for example, these are your data points. So you cannot have infinite lines here. So so this uh, in the y-axis, so the curve that you are seeing, so there we have some certain fixed data points. So these are our points, and by interpolation, we are connecting that. So next, in the next day we will learn about interpolation. So basically you have these points, and this line, it represents the best fit out of what is the best fit corresponding to that data points. Suppose, so these are your points. Now you, to get the points in the x-axis, so what you will need to do, so you will need to define an array. So in x-axis, so for example, you want to plot from 0 to 10, and from 0 to 10 you want to have uh, so for example 100 points. So how can you generate that? So here what do you want to know? So we know the initial value of our array, we know the final value. So this is your in our initial, this is our final, and we know data points. So how many data points we need? So here we are not concerned about step size. So we want to have a decent looking graph. So so at least 100 points we want to have in between this range. So for that, so where we know how many data points you will need, so for that you generally use this linspace function. So if you write this, then you, in this way you can create an X array, and so it will give you 1 cross 100 double matrix. So there will be one row and 100 columns, and for each of the element in the X array, you will have a corresponding Y axis. So so for example, for x equal to 0, you will have a corresponding y value. so sign 0, and then you will have suppose x equal to zero point 0.1. For that you will have some sign of zero point 0.1 or something, you will have value. So it can be sine function, it can be I mean different function also, complicated functional form. So for example, you have x cube e to the power minus x. So for x equal to 0, you will have a value. So x 0. Then for x equal to 0 0.1, you will have some value of this form. Then for x equal to zero point 0.2 maybe. So if, and here you will also have the value of this. So in this way, for each value of x, you will get a corresponding xn. For the last value, you will have a number. So I mean, so these two arrays must be of same dimension. So let me write it down here. So the x array and y array, so I mean which are dependent and independent variable, they must have the same dimension. So once you are done with this two arrays, then you can plot using the plot command in MATLAB, so which is basically just plot x comma y. So first you will write the what you want in the independent axis. So for example, in this case, x is our independent variable. So I will write it first, and then I will write what is my dependent variable. So if I just put this command, so it will give me the corresponding output. So let me show you this in MATLAB. So let me go to the MATLAB environment. Okay, so let me open a new script, and let me save the script first. So I will just name it lecture 3 2D line plot. So this is I will name it. Save. Yeah. So suppose I want to plot the sinusoidal of a function. So I mean, so first let me create the x array. So I mean, let it be an array from 0 to 10, and there should be 100 points. So let us take first, and then depending on the value of x, you will have this y array. So y. So for example, our suppose our function is x square. So how you will write this? So will you write this, or I mean different? So let me check the output first. Yeah. So here you can see the error. So incorrect dimension for raising a matrix to a power. So I mean, what do you want? So I mean, you have this x array where you have this numbers from 0 to I mean 100, 0 to 10. So this is your corresponding x values, and you want the squared of it for each element. So if you want element wise operation, then we have learned with that we have to use dot square. I mean, if you put it, and now let me run it again. So so now we can see that we have these two arrays of same dimension. So if I want to plot it, so I have to write down just plot. So the dependent and independent variable. So this is just the basic command for plotting. So if I do it, run it, you can see that a new window here have popped up, and we can see that uh, this is, I mean, so there is no axis and so on. So I mean, you can do that. So how it can proceed? So if you want to say, I mean, in a plot, in a decent looking plot, you want to give the labels to the axis. So for example, you want to put some name in the x-axis. You have to write x label, and here you have to write what you want to name. So for example, suppose this is your time axis. So you will write down the within the string you will write this time, and you can see that it is updated now. Similarly, you can put label to the y-axis, and if you run it, so you can see that it has updated the y-axis now. And also you can put limit to your axis. So suppose so while for putting limit, so for example, I want to observe the train between 0 to 5. So I don't want the whole range, I want to see what is happening in between 0 to 5. So for that you have, if you run it, so you can see now that 0 to 5 is now showing. So when you can increase, you can change according to your preference, according to your need. So I mean, is from 0 to 20, and in this, so let me just make it 10 now. So I mean, to for generalization, so I mean, you are basically taking the limit of this x array. So what you can do, so you can put here x uh, 1. So this is the first element will be your initial value, and the last element of x, that will be your last value. So if I do it, so I mean, if I change it now here, it will be automatically the limit will be updated. So you can see now that it is being updated. If I make it 50 now, so you can see that it has been updated to 50. And now uh, so in this axis, so we don't have data point for each of them. So for example, let me show you with 10 data points. So we have this. So now what are the data points? So this is our initial data point, and then we have this data. So in between there is no data, and it is, I mean, MATLAB is basically using its inbuilt interpolation, I mean, which you will learn again at the later day. But so I mean, if you want to know where the data points are, so for that here you can uh, write this command. So you can, if you just put o within the string, so it will show you what are the data points are. So these are the data points that you have, and if you want to show the connecting line, so you have to write this, and if you run it, so you can see that this is our data points which are present, and this is the connecting line. Now you can change the width of this line. So to change it, you have to write this command. So line, so I mean width, so you can see here. So let's make it 2 first. So let us see what happens. You can see that it has been increased, and you can change it. So make it 1.5 and run it. So you can see that its width will change correspondingly. And suppose we want to change its color. So I mean, the default color is blue. So if you want to change the color, so for that the command is, I mean, if you want to make it red, so you have to write here R, I guess. Okay, so this is not uh, so you can go to MATLAB, plot help, and it will show you the documentation. So yeah, so here you will see how to plot different kinds of data. So you can see, so let me check what is the command for color changing. Okay, so maybe the order is changing because right now it is working. So line 6, okay, fine. And let me put it now to check it now. Maybe I cannot put after where I cannot put this. Check if it is working this way. Okay. Now it is working. So basically, when you are giving multiple this line specs, so I mean you want to change the color, you want to change the line width, and you want to change the marker style also. So in that case, so first within this second column, you have to write what is the property that you want to change, and you have to give the corresponding sign or corresponding change that you want to do. So for example, I want to make the color green, so I have to make line it green. So for example, suppose I want to show the data points by O. So if I write it, so I will get it here. So and you can see here that these are the different markers that you can put in your plot. So you can put square, you can put diamond. So let me check with diamond. You can see that it is correspondingly updated. So this is how you can change the your plot And also you can add grid to your plot. So for that you have to write down this grid command. So grid on. So now we can see here that the grid has been updated. And also you can plot title to, I mean, you can add title to your plot. So for title adding, you have to write the title within the first bracket. And I mean, so let us put this title, the plot of quadratic function. So you can see the title has been updated here. So in this way you can add, I mean, title and so on to your figure. So also you can add legend. So for legend, so you can search here and look for, so what is legend? So let me show you. So legend MATLAB. So suppose you are plotting multiple uh, data to your plot. So for example, here in the same graph you have two plots. So one is cosine, and so which is this blue one, and another one is cosine of 2x. So you have two different function. And I mean, so suppose you have been and from this data, I mean, you don't have idea which graph corresponding to which function. So for that you can add legend to it. So so if this is the simplest way you can write your legend. So I mean, in our case, so you can add the legend here. So legend. So let me show you what the legend is. So I'm just putting the x square plotting. So you can see that it has been it is showing. And you can, I mean, add also multiple things to legend here. So so you can tell its location also. So for example, where you want the yeah, your this box to present. So you can put this location, and let me just copy paste it. I mean, it is always available, so you can search for it and you can add it in your plot. So x square, and let me put it location at northwest. So let me run it. You can see that it has been changed. So I mean, you can change your location again to other places also, and you can put it to other places if you want, southeast and so on. I mean, you can play with different kinds of things. So you can change, I mean, you can change the font size of this legend also, and so on. So, I mean, you can go through the documentation portal and you can look for how to make the graph looking more beautiful. But this is the general idea of how to plot a 2D function, how to plot a 2D function. Now, suppose you want to plot multiple functions in a graph. So, for example, you want to have this x square, and you also want to plot another function. So, for example, you have this y equal to, for example, x, and so maybe sin x. So I mean, MATLAB has this inbuilt sine laboratory, so it knows what sine function is. So you have to just write the sin x and it will create an array. So since you are plotting two functions, so let me rename it as y1 and make it as y2, and let me run it. So we have now this two y1 and y2 array. So this is now so let me, okay, so now you can see that it shows an error because here we have plot x y, but since I have cleared everything, now MATLAB doesn't know what y is. So last time it ran because it knows what y was because it was initially stored. But since after that I have cleared the workspace, so now there is nothing called y, and MATLAB doesn't know what y is, so it is showing us error. So so let me plot the y1 first. So this is how the x y1 look like. Now so suppose I want to plot this one, plot x y2. Just plot x y2 and rest of the things. I mean, just copy paste it. So color for now, make it red, marker O. Let me run it. Okay, so what it is doing? So first it will run this, but since I haven't defined any figure, so it is updating the second plot in the figure 1 itself. So I mean, if I want to plot them in different figure, so it I can plot the first one in figure 1, and if I want to plot it in another figure, then I can write the corresponding figure name. So suppose I want to name it figure 10. So now let me run it. So now there will be two figures. So in the first figure is figure 1, so which is just the plot command, but then so for each figure you have to give the corresponding title, if for label, legend and so on. So these all corresponding to a particular figure. So when you are defining a particular figure with a name, so these are first figure. So here if you want to add the legend and label, then you have to define here after the plot command, because after that it is going in the figure 10 environment and it is updating, it is plotting in the figure 10. Now suppose I want to plot both of them in the same figure, so what I need to do for that? So I have to just write the command hold on. So what it will do now? So it will first plot this figure and it will keep, and if you hold if you write this command, then it will the next plot it will update in figure 1 unless you are write the command holding off. So hold off, and then if you want to plot something else, so plot then it will, I mean, if after that if you have some plot command, so it will plot in other figure. So this is how generally hold. So now let me run it. Okay, so now you can see that we have these two figures. So the green one is for this x square function, and now legend, in legend you want to, maybe you want to add the second one also. So first one is x square and second one is for x, sin x. The command here. So let me run it. Okay, so this will show you how the figures will look like. So but I mean the y value of this is so much large that you cannot see the sinusoidal variation here. So let me put a different. So let me put some exponential decay also here. So that, so, and here you have to put the multiplication. Uh, so this is your exponential function and this is your sinusoidal function. So let me plot it up to 20 and have more number of data points. Uh, so here you can see, so this is your exponential graph, I mean the first function, which is x square sine x square. Okay, so you have to define it in the second bracket. I mean, uh, second bracket. Let me run it now again. Yeah. So now we can see that which graph corresponding to whom. So that maybe south west will be a good position for this. I mean, you can and also you can change. I mean, maybe yes. So there is way you can change this box size also. So in the help in the documentation portal. So maybe in the documentation portal you can find that. So this so this is how can you can plot multiple graphs in a multiple plots in a single figure. So I mean you can have different kinds of function also here. So let me show you how to solve a problem. So this is how basically you do the 2D plot, 2D line plot. So this is the way of doing the line plot. So I mean there are other ways also. You can do the scatter. So there are way of scatter plot, and there are ways of so there are the bar plot also. So first let me so now I will introduce you to the concept of bar plot. So, what is bar plot? So, bar plot, I mean, so it is useful for visualizing, I mean, or for comparing data sets. So, for example, you run ice cream shop and you want to know. So, suppose you have three different flavors of ice cream, and you want to know what is their sale for different days. So, what you can do. So, for simplicity, so suppose you run it from so you maybe you take one day break. So you will run it from Monday, Sunday. So you run it from Sunday to Friday maybe. So you have 6 days uh, in which you run your shop, and you have three different flavor ice cream. So for example, zero is your Sunday, one is Monday. So for simplicity, suppose you are defining your days like this, and six. So, so if it is okay, so let me start from one. So it will start from one. So Sunday, Monday, and six. In this way, six will be your Friday. So Saturday is off day, and each day, so you have three different flavors of ice cream, and you want to check what is their sale. So for example, you have vanilla, chocolate, and strawberry. So the sale number, so maybe 20, 30, 25, and here also I mean 21, 23, 27, and so on. So you I mean each different day. So maybe Sunday will be a larger sale, 40, 60, 55. So here maybe you will have numbers like 27, 26, 29, 37. So I mean you know the numbers, and now suppose you want to compare what is the how is your sale will look like. So you want to visualize your progress of your shop. So how your sales are going and so on. So what you can do. So I mean here you can have this independent win. So you can write them here. So this one represents your Sunday, and in Sunday, I mean you can plot bar. And the height of the bar represents the number. So for example, this is 20, this is 40, 60, and this is how you. So this is your bar. So in each day you will have three numbers. So 640, and you will have 60, and maybe 45. So this is your sales for three different flavors. Then you will have your second day, and here you will have some different numbers of sales going on. So in this way, you can visualize how your sales will look like in each day. So this is generally known as bar plots. So this type of plots are go to compare or visualize data. I mean, instead of plotting this side by side, so you can put it stack. So you can put it on top of this and also put it on top of that. So I mean, and if you plot it on in the top wise, so I mean, you will also get a visual idea of what is the percentage for each of these. So each day you will know how many percentage you are selling this flavor, how many percentage you are selling this flavor, and what is the percentage you are selling this flavor. So this is how you can visualize this kind of bar data with this bar plot. So also, I mean, you can run, you can think of it with the term of experiment also. So for example, suppose you are running some experiment, and so suppose you are doing the same experiment for 5 consecutive days, and for example, you have, and so what you are measuring. So for example, suppose you have three different energy levels, and I mean, you suppose you do an atomic experiment setup, so you have three different energy level, and you are measuring what is the number of atoms uh, in each energy level. So, I mean, in each day, so maybe the temperature will be different, and due to the different experimental conditions, so maybe in each day you will have different number of these atoms. So you can visualize how your data, how these atoms will be distributed for each day. So let me try, let me do this in MATLAB. Okay, so for this first, I need to create an array. So for example, consider the example of this experimental setup. So I mean, you are doing the same experiment for 5 days, for example. So you want to name the, I mean, days from 1 to 5. So you have to create an array. So let me write this an X array. So it will start from 1, the 1 will be the gap, and it will run up to 5. And for each of the 5 days, so I mean, you will have, so suppose you want to know what is the number of, I mean, particles in three different energy levels. So you have to create a 3 cross 5. I mean, so there will be five number of rows. I mean, so five. So you will have. Okay, so let me create the matrix first. So, for example, if you want to create a simple array, so y so particle array. So what you will do? So for x equal to 1. So for 1 day, you will have three different numbers. So maybe that will from 10 to 3, and for the next day you will have three different number. So you have here what, three column and five rows. So you want to create a matrix with five rows and three columns. So I will just use this so that it will be created faster. So I want to, for example, take the numbers from 10 to 20, and there will be three rows and five columns. So let me run it. So let me clear everything first. So let me run it now. Okay, so this is our X array where each of these numbers, so this is your Monday, Tuesday, Wednesday, Thursday, Friday, and for each of the day, so this is how your measurement look like. So let me open the particle array. Okay, so for each day, so this for Monday you are measuring what are the number of atoms stored in three different energy level, and it gives you this three number. This is for a different day, and this is for another different day. So this is how you can store this. Now for this bar plot, you have to, I mean, when you're plotting, you will define the figure number. Then you have to write down this command rule, just bar. So first you have to tell what is your x array, x column is. So this is your x array, and with x array you want to have a bar plot of the particle array. So if I run it, so I can see that this is for Monday, and this is the number of atoms in the X. I mean, in first energy level, this is in second energy level, this is in third energy level, and this is the similar experiment we are repeating in different days. So here I mean, so I have to save this first. So let's save it as lecture 3 to be. So it will be bar plot. Save it. Okay. So this is how we can create a bar plot. So in X, then we have to put this X level, which is days, week. You can write just week, days. So let me run it and let me check if it is working. So yeah, X-axis you have weekdays. On Y-axis, what you are plotting. So here you are plotting. You don't need this. You can omit this. So here you have number of particles in different energy levels. So let me run it. So I mean you can make it smaller. I mean you can also change its font size also. So particles in different energy levels. So you can see that so this is a way you can visualize your data. Now from this particle array, I mean you so you can uh, find what is the maximum number of particles stored. So you can create an array where you can store the number of particle in first energy level for different days. So I mean from that you can get what will be the maximum, what will be the minimum, and so on. So this is the use of the bar plot. So in this way you can also work with this. I mean different kinds of problems. So these are just interactive ways of visualizing data. So you another thing we so there is also scatter plot. So in scatter plot, I mean it doesn't we so in line plot what we have observed. So when you are plotting something, it generally connects the number of data points. But in scatter plot, so I mean it generally doesn't connect. So for scatter plot, so let me create an array first. So let me create array where I will have random number from 1 to 10, and this is 1000. So this is your X array, and you can have your Y array similarly. In Y array, let me take the numbers from 20 to 50, and you have one row and 1000 column here again, and you can have a scatter product. So scatter X, then you have your Y. So and let me define it as figure 2, and let me put the first portion in comment. So let me just run it. Yeah, so you can see that it doesn't connect to two lines. So let me just reduce the data point for now so that you can understand. So these are the data points. I mean you can fill them. So for that you have to write this fill. So if I just put it fill here, so you can see that these data points are filled, and you can also change its color. So if I want to, for example, fill it with yellow, so you can do it yellow, you can do it with green, and you can also have maybe a green on. So let me check. I'm not sure of this. Yeah, so you can have your read on. Also, I mean, so in this way, you can you can search for correlation in your data set. So, for example, you are having data from your experimental setup, and you just, I mean, you don't know if there is an underlying correlation between both the samples. So, let me check if it works with different. Uh, okay. So, vectors must be a same length. Okay. So, I mean, you can check if there is any correlation between the data point. So, if there is a linear correlation, for example, y equal to uh, so let, let me write down this. So it will and it will add with x. So there should be a linear kind of trend. So if I run it, so you can see that there is a linear trend of y. So that means the data points are correlated. So for example, from your experimental data, so if we are having these points, and this is how if you will create y array like this, then from looking at the data set you can tell if there is any correlation between the data point or not. So scatter plot is generally a good way to look for correlation between the parameters from your experimental data extracted. So these are the, so most used plots used in, 2D plots plots used. So you have a line plot, you have the bar plot, and also you have this scatter plot. So now I will introduce you to the 3D plot. So let me create a PPT which we have created earlier. Okay. So, okay, so for example, if you are doing a three-dimensional plot, so now instead of this both x and y axis, you have another axis which is z axis. So, and if you want to, for example, suppose you want to have a line plot in 3D. So, whenever you want to have a line plot, so be it in 2D, 3D, or in any higher dimension, so in that case, there will be a single independent parameter. So, for example, in case of 2D line plots, so what we are doing, so in the x-axis, we are having the independent parameter, and in y-axis, for example, if you are plotting sin x, then the y-axis, which is sin x, is the dependent parameter. So in that case, we have only one independent parameter. In 3D also, so when you are dealing with three axes, so if you want to have a line plot, so here also you will have only one independent parameter. So for example, consider this graph. So for example, you have this kind of relationship. So x is equal to e to the power z by k sine omega z, and y is e to the power z by k cosine of omega z. And z here is the independent parameter. So depending on the value of z, the value of x and y will change. And if you want to have, so for example, this is your z array. So for example, you have these n points, and for each of the z value you have to calculate what is the value of x and y. So you have to do the element wise operation on x and y. So you have to take the individual element from the z array, and you have to do this operation, and you have to create an array of x and y. And from both three from this three array you can use this plot 3 command in MATLAB, which generally plot the line plot in 3D. So this is how it will look like. So so for a fixed value of z, this will be a number, and you it will perform a circular motion for a fixed z, and as we keep on increasing z, then we can see that there is this cyclone like figure which is being generated from the line plot. So let me show you an example. Let me show you in MATLAB. So let me. Okay, so for example, you have this jet array. So one, two. 10. I mean, maybe in steps of 1. So let me just visualize it. So this is our Z array, and so let me just clear all first. CLC, and you are creating a Z array here, and depending on the value of Z, so you will have your X array. It will be for so simple Z by K. So K is I mean parameter which you have to define. So I mean otherwise whenever MATLAB will go here, so it will search for k in the previous lines. So if that is not there, so it will give you an error. So you have to specify what is k. So k for now we can take, I mean, just assume it to be 2, and we will look at how the graph will look like. And you have to multiply it with, I mean, you have to have the element wise multiplication. So you will have here sine omega. So I mean j. So omega you have to define. So let me define it as 5, and this is your x array. So you can similarly create another array which is y array, and instead of sine, let me have here cosine. Okay. So let me just run it, and first let me save it. So save as lecture 3 3D line plot. Okay, and let me run it. So first it will clear all the variables that are stored, and it will create an array. So this is our Z array, and depending, and for this Z array we have created this x and y and x and y array. So for 3D plot we have to use this plot 3, and here you will have x, y, z. And let me check how the output will look like. Okay, so I mean it doesn't look like similar. So, and here you can see that there are very few data points, and so these are the data points present. So I mean you can increase the number of data points. So let me do 8.01, so that, or I mean let me just use the linspace function. Let me 1 to 10, and there should be 200 data points. Let me run it here again. Okay, so now something more interesting. So and this is how the exponential factor will change. So if I increase k, so that and let me look at the plot now. Yeah, so let me make it 10. Yeah, so if I make it 100, so it will, I mean, larger uh, divergence we will be able to observe. Mm, oh, so if I make it smaller, then we will be able to observe larger divergence. Yeah. So in that way, you can, I mean, check the dependency on the parameter also just by plotting the function. So this is how it will look like, and how this will change this figure. So I mean this is the frequency. Yeah. So this will change the number of rotations because this is the frequency. So let me make it to 10. Yeah. So this is now looks almost uh, similar. Let me increase it the data points. Yeah, and let me make it 2 or 4. Yeah, so something interesting. So something almost similar. So in this way, you can, I mean, uh, generate this kind of plot. You can do the 3D line plot. So you can put labels also, x label, you will write here x axis, then you will have y label, and here you will write y axis, and then you will have z label, and here you will write down z axis. So let me run it. Yes, so now we can see all of them axes are present. So maybe grid on. Yeah. So line uh, line width you can increase maybe 1.5. Yeah, so in this way, I mean, you can check the dependency. And so if I make it negative here, so it will be exponentially decaying. So you will see it will converging. So let me run it. Yeah, so you can see you can see that it is flipped. So in this way, you can I mean explore with different kinds of function. So we have this function here. So I mean you can check with different function. But the key concept in 3D line plot is that whenever you I mean uh, I mean, whenever if it is in 3D, 2D, 4D, higher dimension, doesn't matter. So line plot basically means you have only one independent parameter. So in that case, we have Z as an independent parameter, and depending on the independent parameter, the values of other axes. So here we have three axes. So that is why you have this X and Y axis. So their value will depend on this with the single independent parameter. So this is the way you can create a line plot in 3D. So now let me come to the surface plot. So I mean, whenever we're talking about surface or something, so I mean we know that surface or plane it generally means we have two independent parameters. So line means we have one independent parameter. So I mean, so line is in 1D. So that is why it is one independent parameter. But if we are talking about plane, so that means you have two parameters which are independent, and depending. So if you are having a three-dimensional plot, and if you want to have a surface plot, so that means you have so here in that case x and y axis are the independent parameters. So these values you will take independently. This doesn't depend on each other, and the value along this z axis. So that is a function of both the independence parameters. So here you can see that j that is a function of x and y. So that functional dependence can be, I mean, it can be a constant, it can be a very complicated function, or it can be a function written like here. So I mean, it can be very basic also. But the key concept is that whenever you are having a surface plot, so for surface plot, you have so I mean, whenever you are dealing with a situation where you know that there is this two independent parameter, and there is a parameter which depends. So for example, you want to know how the frequency will change as a function of temperature and pressure. So what you can do? So you can take pressure to be an independent parameter. You can take temperature to be an independent parameter. And so for example, you know the functional form by which the frequency that depends on temperature and pressure. So for example, I mean, so for simplicity, for now, consider this is the functional form. So x is our pressure axis and y is our temperature axis. So I mean, so I can create an array of this temperature axis and pressure axis, and we can look at how the frequency will change as a function of both the axes. So in that way, we can proceed with this mesh plot. So here you can see, so it is written that this is x and y axis, these are independent parameters, and z is the dependent parameter here. And so we will have this xi and yi, and zij is a function of this xi and yi. So this is called mesh grid. So and I mean to create this surface, you have to use the mesh grid function, which is inbuilt in MATLAB. So what is this mesh grid? So for example, to create this kind of grid, to create this surface, So I mean, with this 2D surface, I mean, you are so for example, these are our x data points. So first we have to create an x array. So where whose row is 1 and column is m. So here we have m numbers in the x array. So we can create that. So I mean, if you want to create an array from 1 to 10, then in MATLAB we have to write x, which will be equal to from which will run from 1 to 10. So in that way, you can create the x-axis. In a similar manner, you can create the y-axis also. So once you are done with the creation of both these axes, then then you have to write this mesh create function in MATLAB. But what it does, so it is an inbuilt function. So what it basically, so we have this two array, and so if you want to know what these points are, so for each of these points the x value will be same. So for each of these points x is x1, but y value will be different. So for here it will be x1 y0, here it will be x1 y1. So for example, here it will be x1 y2, and here it will be x1 y4. So I mean, depending where you want to know, so along this axis you will have different y number. Similarly, if we go along this axis, along this line, so here y will be same. So for each of these point y will be y1, but here your x will be different. So here you know it is x1, it is x2, x3, x4, and similarly so on. You have different x point, but your y point is different. Y point is same here, but x point is different. So that means you are basically creating a grid. So if you write this mesh grid command, so if you give MATLAB this array and write this function, so it will create these data points for you. So I mean, it will create an n cross m so array for you. So where n is the, I mean, the row number. So then the length of this x array, so that will be the column number, and the length of this y array, that will be its row number. And from this mesh grid, so I mean, for each of these data point, so for each of these point, if I go to the next slide, for each of these point you will have different z value. So I mean, you have the functional form, and for this each xi yj there will be a zij. So z11, for example, for it will be z11, it will be z34, it will be z41. So you can know what is the value of this what is the value of this z, which depends on uh, two independent parameters, which is x and y. So once you are done with the creation of this z array, then you can write down this mesh command, which will so from this mesh command, so it will plot this kind of it will give you this kind of plot where this point, these are our data points, and this is the z value. So here we know what is x and y, and for that it will calculate the z. And so it will and if you write this mesh command, so what it will do, it will connect all the points with line. So you have a data point here, you have a data point here, and it is connected. So and in between regions are not filled. So you will have something like this. And you can also write this surf command. So basically surf, so here you are doing the surface plot, but the difference is that now it assign a color to it, and what this color represent, so the intensity of this color, so it will represent the value. So I mean, you will have a color bar here, and the value corresponding to each color will be shown. So I mean, that I will show you right now in MATLAB. So but this is the main difference, and this is how do any 3D plot. So you have two independent parameters. So here first you have to create the mesh grid, and once you are done with the creation of this mesh grid, and depending on this, I mean, you will write the functional form, which will calculate the value of this j at each of these data point. And if you write down this mesh command or surface command, it will give you this kind of plot. and you can also have contour plot. So contour plot basically means it so it is a way of visualizing the 3D data in 2D surface. So here this what these lines represent. So for example, for each of this line, so z value is the constant value. So for example, we know equipotential surface. So I mean, when we have learned electricity and magnetism, I mean, so from electricity and magnetism, we know what are the equipotential surface, where the potential is same. So you can think of Z as the potential, and this this line. So for example, this circle, it represents. So for example, here each of these points we have Z value to be 10, and here for each of these points we have Z value to be 9, and here for each of these points we have Z value to be maybe 8. So this is how you can read a contour plot. So basically, contour plot, it is just a way of, it is just a projection of a 3D data of a three in a 2D surface, and where each of this circle, it represents I mean a, a surface. I mean each of this circle here represents a constant Z value. So and each of them will have different Z value, but for a particular circle, the Z value will be same. So now let me show you this in MATLAB. So let me create the X array first. So X array. So in space from -5 to 5, maybe 100 data point for now. Then you will have your Y array. You will write space, and here similar, for example, consider this similar point 100. So you are getting, and you can take different also. So let me proceed with different. So that will be, I mean, that will remove the illusion that they have to be of the same. So we have created the x and y array. Fine. Okay, so let me start with this clear all and see and see. Okay. And this is our x array, this is our y array. And whenever you are so right, the way of creating the mesh grid is that you have to so write this mesh grid. So mesh grid, you have to create mesh grid of what? Of x array and y array. So this is your x and y. So y array. So it will create a matrix so of different dimensions. So if you want here 50 data points, so in the mesh grid, so if I save it, so let me store it in Z. So let me run it first. Check 3, mesh, and I will show all of them here. So mesh surface plot and contour plot. Okay. So let me run it. Okay. So you can see here that this is our x array, this is our y array, and if I store it in, so the way of storing it, you have to write the two components x y, and let me should not be y array. So let me run it. Yes, you can see that it has created this 100 plus 50 double number. So this is your so this is, I mean, so the column number, so that is uh, that will be the length of the array of the x-axis. So here x array is your x-axis, which is 50. So there should be 50 columns. check. Yeah, so you can see there is 100 row and 50 column. So in that way, you can create this mesh grid. And now what you have to do, you have to write down the functional form. So I mean, so for example, Z you want this maybe. So you have to do element wise operation, and you have to be careful because you uh, I mean Z array should be of same dimension of this X and Y array. So that you have to be careful. So you have to do X squared. So Y. So this, I mean, you can take negative. You can, and you can put the whole under the exponential, and you can multiply it with x again. So the functional form which I have shown in the PPT, and here should be dot star. So this is how you will create your Z array. So let me check the output. Let me run it first. So you can see that we have successfully created the arrays. So these are x. I mean this x y. This is our data points in the plane, and in the z it gives you value for each of these x I y j. So for mesh plot, so you have to write this mesh. Here you will write x, y, and z. So let me run it. Let me give it a figure and name. So it is figure one. And if I run it, then you can see that this is how the array will look like. I mean, you can change. I mean, you can increase or decrease the number of data point. So you can make it 50. And let me run it again. And you can decrease this limit. So maybe 2 to minus 2. Here also 2 to minus 2. Yeah. So this and here what you can do, you can also rotate it. I mean, you can look at the data from different angle. So and so you can also have the color bar also. So before that, so let me show you the difference between the mesh plot and surface plot. So in figure 2, let me have this surface plot where you will have x, y, z, and for example in figure 3, let me have the contour plot. So contour, and let me run it. Okay, so for contour, I think we don't need execute y, z, put co. Okay, so maybe I have written down this. Okay, contour. So let me run it again. Yeah, so this is how your surface mesh plot will look like. This is how your surface plot will look like, and you can see, and you can put color bar on in each of this, so that I can explain what does this color bar signifies. Okay, so let me go to first figure. So I mean, this here you can see that the yellow, where the color is yellow, so that value is higher. So I mean, for example, this kind of color it has for, so in this plot, wherever, so for example you are looking it from the topmost angle, from you are looking it from the above. So when you are looking it from the above, then I mean you can tell from the color bar, then at along this region the value of z is larger, and along, I mean, this region the value of z is smaller. So by looking at the color bar, and by looking at the project, and by looking from the top surface, you can tell what is the value of z
corresponding to that grid point. Then you have the and here we have surface plot. So here what it has done, so it has also uh, just instead of putting lines only, it has also filled the regions with. So it has interpolated what should be the value between the data points. So, and if you look at it from the top, so here you can see that, I mean, so in between points they are also interpolated. So from, I mean, so next we will learn interpolation. From interpolation function we can know what is the value at that z value, so at that x and y. So this is how, I mean, you can uh, interpret a surface plot. So I mean, in this region you have this maximum z value, and in this region also, and here you have, I mean, lower z values. And in the contour plot, I mean, so for example, this is for z value 0.35 maybe, this circle corresponding to maybe point 0, around 0.05, and for this circle we have a constant z value which is around point, maybe 0.15. So you can go to individual, I mean, documentation here. You can look, I mean, you can look for commands to, I mean, look it more beautiful, to like look it more aesthetic. So for example, in this plot, if you want to remove this line, then you have to write down this command that color, let me check what it is. I have already created something. Okay, age. So you have to write down this command, age color none. So let me go to the problem again. So you have to write down here age color none, and let me run it again. So if I run it, so now you can see that this age, the connecting lines. So it is, previously it was connected with black dot. So what was the problem initially? So let me do it again. So if I increase the number of data points, then you will see the problem. So just let me comment it now, and let me increase the data points. So maybe 500 data points, and let me run it. So I mean, here it looks fine because it connects, I mean, all the data point. But here you can see that it is all black because the connecting lines. So these black lines are, I mean, so there are large number of data points. So it has make everything look black. So that is why you have to put this edge color none command, and let me just comment it out, and let me run it again. So this is how your surface plot will look like. This mesh grid plot, and this is how your surface plot will look like. I mean, for large number of data point, it almost looks similar. But if you are working with, if you check with smaller number of data point, then you will able to see what is the difference. I mean, this is a pretty looking graph. So I can see, or you can see that here we have very large Z value. So for example, this 0.36. Here we have Z value 0.00404. So in this way, you can, I mean, look at this uh, axis, and also you can change. I mean, uh, you can change the function. So I mean, you can try with different function. So maybe instead of, I can remove, I can put this only x, and let me run it. Yeah. So now you can see that is a. I mean, this is how. This is pretty. So here we have the lowest value of z, and it is going in the negative direction. And here we have a positive value of z, and it is around zero point 0.04. So this is how you can, I mean, visualize the data, and you can look for different angle, and you can also export the data. You can also export the figures. So I mean this. So here what you have noticed, I mean, this task of creating this. Uh, so creating this image grid. So this task MATLAB has done in only by only one command, and that is mesh grid. So somehow MATLAB know what mesh grid is. So how we can know it? I mean, so there is some inbuilt function. So what is this inbuilt function? So you can define your, so it is already pre-installed in MATLAB, but you can also define your own function. So now I will mm, tell you how to create a function in MATLAB. So let me go to function MATLAB. Let me just show you it first. So in function, so while writing a function, so for example, you have to start it with this function. So that MATLAB knows, so the MATLAB can know that you want to define a function in your function. So it can be a very simple function like calculating square of a number. So let me start with very basic. I mean, so for example, I tell you to create a function where you will just give. I mean, you will give the radius, and the function will give you the output of the area and circumference. So so to do that, so first you have to tell MATLAB that you are creating a function. So that is why you have to write function. So MATLAB will know that you will create a function here. Then you have to tell what is the output. So for now, let me write it as output. So this will be our output. So this output can be a scalar number. This can be a matrix, array, and cell also. So lot of complicated things, but it is the output that your function will give. So for example, if you want to calculate the circumference and area, so output should give you area and circumference. So it should have two outputs. So it should be a 1 cross 2 array or 2 cross 1 array. So and the two elements will be, one will be circumference and one will be area. So this is your output, and then you have to give a name to your function. So let me give the name calculate area circumference, and then within bracket you have to tell what is the input that you will give in the function. So what I have tell you to calculate is to I mean, you will take the radius as input. So here you can define a you have to tell a variable name. So I mean, when you are writing this function, so I mean, mm, it is not necessary to define it earlier. So what MATLAB will read? So MATLAB will read that it has to create a function where it will take only one input, and depending on the performance, I mean depending on the task, after that it will give you a output. And so whenever you are doing function, you have to end it. So in between you have to write this. So R is our radius. So what is the formula for calculating area? So area we know is pi. So pi is already defined in MATLAB. So pi and R squared. So R squared. So this will give you the area. And if you want to calculate the circumference, so it is 2 pi r. So this is your circumference. So this is the way in which you can create a function. So now you have to define what the output is. So initially you can here you can create this output to be a blank array, and you will append this number in your output array. So output, so where you will append this area. Output initially the blank array, and if you want to append it in row, in the next column, I mean in the same row, then you have to give comma. Or if you want to append it in the column, I mean in the along row wise, then you have to give semicolon. I mean depending on what you want to do. But let me give comma here. So what you will store? You will store the area and you will store the circumference. So this is the function definition is done. So what it will do? So I mean, if you now what you have to do, so this function is ready and you have to call a function. So if you do this, so this is your function. So for example, suppose you are writing a function to define a to suppose MATLAB doesn't know what sine function is. So in that way you can create your own sine function. So you know what is the series expansion. So you can write the series expansion rule here, and after series expansion and doing the addition, the number that you will get, that you can store as output. So so whenever we are calculating uh, sine of x, we are writing sine of x. So MATLAB has this inbuilt function. It will take the x value and it will give you the output of it. So now, since we have created this function, so in the similar manner, we can instead of so we can write this and we can give x as an input. We can take x as an input. So you can write here enter the radius, the circle. So I mean, so how it will proceed? So first you have to enter the radius here, and then MATLAB what it will do? It will so look at this cal area circum, and it will look for function. I mean inbuilt, if it has any inbuilt function or not. So since it doesn't have any inbuilt function, then it will check in your script, and in your script there is a function which you have stored it with the same name. So MATLAB environment will go here and it will pass x as an input. So the x value will be passed inside this function and it will calculate the area, it will calculate the circumference, and it will append to the output array. And this function will give you this output. So I mean you want to store the output somewhere. So I mean you can also write here out array. So the output of this function, so that will be stored in your out array. So now let me save it. Yeah. So we can clear all CLC. um, just remove them and let me run it. So first you have to enter the radius, for example 3. So you can see that what is the first one. So first one is your area, and this is your circumference. So in this way, in your output array, you can so I mean you can check with different numbers. So maybe 2. So for 2 it will be same, because the I mean if you put 2 here, so both of the numbers will be same. So in this way you can create a function. Now you can create you can call a function inside a function. So for example, I mean this so let me give you this example. So instead of writing this, I can create another function which will calculate the circumference, and I will call it here. So how we can do that? So for that we have to create another function. So function, and which will give me the circumference. So I'll just put this output as this name, circumference. Then I mean calculate circumference. So this is the function name, and I will give the radius as an input. So it will calculate the circumference, which will be 2 pi r, and so what this function will do, and you can call it here. So let me run it. Okay, so there is some error. Let me check what is. Okay, so what? Let me check it. What it will do. So it will maybe have to pass it here. Check it. This it is not creating this way. Check how to do that in step function. Okay. Okay. So I have written down the name wrong. So now it should work. Yeah. So I mean, you don't have to do anything. So I mean, in between a function, so it whenever how it will proceed. So first you will give the input, then it will I mean uh, check if there is any function like this. So it is present. So it will go to this function. It will take this input, so which is your x is an input, then it will create this output matrix, empty array, then it will calculate the area, then it will go to this line, and you know here we have this calsa. So it will again check if there is any function available. So there is a function available. So it will in this line it will go here, it will execute this line. So I mean you can put different index also. I mean the index doesn't matter inside a function. So I mean this r value will be passed here. Ultimately the x value is being passed on to every function. So and it will calculate the circumference, and it will give you it will return that value here. So that will be our circumference, and that will be stored here. So you can see that it is same exactly which we have calculated earlier. So in this way you can call a function inside a function, and this is I mean this is a simple example. Now I mean you can do more complicated examples using this. So for example, in the last day we have learned about how to check the roots of equation. So we have checked this. So I mean let me run it again and let me show you. So we have 100 1 so from that we have so this is how we have calculated what is this uh, what are the roots. Now suppose you want to do this with a function. So how you can do this? So let me show you this. So here I mean this will be your input, and from that you want to define a function which will give you the output. So you have to write down the function. So you will have output here. So output you can call as root, and then you have to give the function a name. So quad solver, maybe quadratic equation solver, and you have to give the inputs here. So I mean, let let me store them in an array, and let me pass, I mean, or you can pass it individually. So just for example m n o, and let this be in o. So this is our input, and you want to pass this in, you want to define a function where you will pass this input, and the output will be root. So first you want to, so first with this number. Okay, so for function definition, let me check, let me see. So you will give this three number. So first it will calculate, and whenever you are writing a function, so maybe you have to end it. Yeah. So first it will calculate what is the discriminant. So it will calculate the value. So if it is greater than 0, so first let me define an empty array where I will store the roots. So root, this is an array. So what you want to do now? Now instead of printing, you want to just store this. So root, here will store this root 1, then you will store the second root, and you have to put comma here. So if this is greater than 0, your two of the roots will be stored, and then if discriminant is equal to 0, then also you will store, you have to update your matrix. So root, mm, let me give it a different name. So root, so it will be only single root which will be stored here. Also this real part and imaginary part. So I mean, how you can define a complex number. So complex number is basically defined in this way. So you have to, so this is your real part and this is your imaginary part. So in MATLAB there is an inbuilt function called complex, where you have to write down the real part first. So this is your real part, and you have to write down what is your imaginary part. So imaginary part is imaginary part, and what will be your root 2. So root 2 will be the complex conjugate of that. So in front of this imaginary part you have to put the minus sign. So here this is how you will get the root 1 and root 2, and then you want to store them in your root matrix. So you have to write this. So it should store these values and this function. So now this function is ready. I mean, if you look at it, so you will give this three number, and depending on the three number, it will calculate what is the discriminant. So if this is greater than 0, it will it will calculate the roots, and it will store it in the root. Then it will, I mean, it will check for different condition, and it will store root correspondingly. So let me save it. So save as lecture 3 function quad solver example, and now let me run it. So we have to enter the coefficients now. So maybe 100, first coefficient, second coefficient, third coefficient. Okay, so now you have to, I mean, this function has been executed, but you have to call the function. So I mean, an output you will be store, maybe you want to store in this output command, output array. So here you will call this function, and what will be your coefficients. So the order is important. So m n o. So this is your so here you are defining the function, and here you are calling the function. So if I run it and enter the coefficient, so let me check 100. Okay, so you can see that it is giving me output. What should be the root of this quadratic equation? Now we can check with different conditions. So second one is 100, third one is 1. So now I can see we here you can get different output. So this is how, I mean, you can create a function inside a MATLAB, and I mean this function can be very simple, like calculating the square, and this can also be very complicated. I mean, you can increase the complexity. So, for example, this is a function to solve the quadratic equation. How you can solve a quadratic equation? So you can play with it. You can play with different. I mean, you can think of different problem. So different. So I mean, I will give you the problem set. So you can solve different kinds of problem using this function also. So you can try to play with that. So this is for today. So basically today we have learned about basics of plotting. So how to do line plot, that is in both 2D and 3D. And we have learned that line, whenever you are having a line plot, so there you have only one independent parameter, and depending on in which dimension you are plotting, so you will have I mean other axes they will be dependent on that independent parameter. So for example, if you have a line plot in 3D, so you'll have one independent parameter and other two parameters will be dependent on the other on the that parameter. So you can have surface plot. So for surface plot, what we have done, so we have there is an inbuilt function in MATLAB, mesh grid. So if you give this array, so it will create a grid, and from each of this grid, from this grid point, so it will create grid like this. So from this grid, I mean, and if you define the functional form, so it will calculate what is the z value at each of this point. So it will, and it will plot the z value on the plane. So and from the, I mean, from the color bar, you can look at the intensity of the color. So and that intensity will tell you what is the value of z at that particular point. And you can also have contour plot, and we have also learned what is the difference. So in the mesh plot you have only the lines, and in surface plot, so I mean the intermediate regions are also filled with colors to give you, I mean, to give you the visual sense of value. And so there is a contour plot. So contour plot is basically a projection of this 3D of surface plot in a 2D dimension, in two dimension. And here is each of the circle, so they represent a constant z value. And so for example, for this circle we have this higher z value, and here we have this lower z value. So this is a way of visualizing data in, I mean, in different dimensions in 2D, 3D. And then we have also learned how to define a function in MATLAB. So so this is it for today. So next day we will proceed. So we have also learned about this bar plot. So how we can visualize in data, how to compare them. We have also learned about scatter plot. So next day we will learn about interpolation, and also basics of this differentiation and integration. So that is it for today. So see you in the next class.